Using rules of inference to build argument. Use rules of inference to show that the hypothesis, if it does not rain or if it's not foggy, then the sailing race will be held and the life-saving demonstration will go on. If the sailing race is held, then the trophy will be awarded, and the trophy was not awarded imply the conclusion it rained. Okay, so we are supposed to use rules of inference to show that the hypotheses, here are the hypotheses. If it does not rain or if it is not foggy, then the sailing race will be held and the life-saving demonstration will go on. This is a hypothesis. If the sailing race is held, then the trophy will be awarded. And that's another hypothesis. The trophy was not awarded. That's the third hypothesis. Conclusion is it rained. So let's see, rules of inference. What are the propositions? Yes. It rains. Let's say it rained. Q. It is foggy. The sailing race will be held. And the life-saving demonstration S is the trophy will be awarded. The trophy was not awarded imply. Okay. It rained. Okay. So what are the hypotheses? Let's go through the hypothesis. Okay. It does not rain. If it does not rain, negation of P or negation of Q if it does not rain or if it is not foggy, then the sailing race will be held and the life-saving demonstration will go on. You see, that was unnecessary. It's part of being sailing race is held. You can say and the life-saving demonstration will go on. So you can call that R. So this implies this. What else? So that's the first hypothesis. Second hypothesis, if the sailing race is held, then the trophy will be awarded. So R implies the trophy is awarded. Okay. The trophy was not awarded. So the third hypothesis or premise is that trophy was not awarded. So you want to conclude that it rained. That we want to conclude P. All right. So note R implies S. Okay. And not S. R implies S and not S together concludes not R. Okay, let's see why. It's one of the first things. Here we go. Modus tollens. So P implies Q and not Q implies not P. That's what we are doing. R implies S and not S. That's the second guy. That's the conclusion. Does not happen, so your assumption does not happen. So it's not R. Okay. So if it's not R, so this is modus tollens. That's your first argument. What's the second argument? Once it's not R, we can go back. You see, you have not R, so it has to be not this, right? Another modus tollens. So this and not R together implies not P or not Q. You see, not R implies not of this. Okay, so this is also a modus tollens. Now let's understand this. Not P or not Q is equivalent to negation. You see, we are now going to use De Morgan. That is P and Q. You see. Now, what do we want to say? We want to conclude P. Well, P, so that's your first hypothesis. So this, by the way, by simplification, we just saw, where did it go? There you go. P and Q implies P. Okay, therefore, P. This is simply simplification. So that's what we have used. 2 levels of modus tollens and then a simplification to give us the conclusion P. All right. We'll continue our next, the rest of the section in our next video.